Hello everyone. Today in Mathematics Masterclass, we'll be treating percentage error under approximations. Relax yourself and enjoy the tutorial. What is percentage error? For example, if you tell 10 persons to measure your height with different measuring instruments, you will agree with me that they will all come out with different measurements. This error can be as a result of two things. Number one, it could be as a result of human error or the measuring instrument. So in mathematics, we always calculate the percentage of this human error, and we refer to it as percentage error. Let's look at the three ingredients of percentage error. Now, in percentage error, we have two formulae. The first one is percentage error is equals to error over true value times 100%. In this case, the true value of that thing you are calculating the percentage error is known. So we use this first formula. The second formula for percentage error is percentage error is equals to error over measurement times 100%. Now in this situation, you will only be given the measured value. So when you are using the measured value, this type of formula, or when you are solving this type of question, you should know that you always have two answers because you are dealing with range of values. So your answer will either be positive or negative. So we are going to see the examples of each below, and the last ingredient is the error itself. And error is equals to measurement minus true value to get your error. So take note of this as we are going to make use of them in our examples below. Example 1. A. The length of a stick is 8 centimeters. A student measures the length as 8.5 centimeters. Find the percentage error in the measurement. Now, we are going to first of all quote our formula that says that percentage error is equals to error over. Now in this situation, we have the length of the stick as 8 centimeters. That is the true value. Let's true value times 100%. Now, what is our error? Error is equals to measurement minus true value. So we'll be abbreviating this measurement. We can use M, true value we can use TV, error we can use E, and then percentage error we can use percentage E. This is what we are going to use going forward. Now we are going to calculate our error. So we are going to say error E is equals to the measured value we have here, or the student measures the length as 8.5 centimeters. So this is what the student measured, 8.5. So that is the measurement. We have 8.5 minus, now the true value, the true length. The length of a stick is 8 centimeters. So that is the true length. So we have 8 centimeters. So, and this will give us 0.5. So we know our true value, so it's percentage error we are calculating. So we can now write percentage E, that is percentage error, is equals to error itself is 0.5 over true value. True value this time is 8 times 100%. It is 100%, not times 100, times 100%. Take note of that. So the percentage error will be equal to this 0.5 times 100 will give you 50 over 8%. So if percentage error therefore is equals to C whole number 1 over 4% or 6.25%. So this is how to calculate percentage error. This is A. We have answered A. Is equals to error all over true value times 100%. Now we are looking for, we know the true value, we know the percentage error, so we don't know the error. So in this our formula, we'll first of all find the error, because our percentage error is equals to 5%. Then our true value is equals to 20 centimeters. So, but we don't know our E, which is the error. We don't know the error. So let us first of all find the error. So how do we find the error? We substitute all of this into the formula. So we have 5. Now the percent is already there. Is equals to E over 20 times 100%. So 2 times 20 is 100, which is equals to 100% times E. Don't forget this is 5%. This will give us 100% also. So 100% times E give us 100% E. So we are looking for E, so we have to divide everything by 100%. Divide here by 100%. Divide here also by 100%. So 100% cancel out 100%. 100% into 100% is 1, and that will be equal to E. So we now have our error E to be equal to 1. Now since error is equals to 1, and we know that error itself is equals to measurement minus true value. Now we know our true value, we know our error, but we are looking for measurement. We are looking for M. So if we make M the subject of the formula, we are going to have a true value, and this will give us, remember we are asked to look for possible value, two possible values for measurement. So since we are looking for 2 possible values, our error will be plus or minus 1. So here now we are going to write plus or minus 1, and that means that our measurement will be equal to 20 minus 1 or 20 plus 1. So the possible value of the measurement is equals to 19 or 21. So let's consider example 2. A square is 10 centimeters by 10 centimeters. A student measures a side of the square as 9.9 centimeters and uses the measurement to calculate the area of the square. Find the percentage error in the length of the side. B, in the area of the square. So let's start with A. So let's draw the square. The original square is like this and is 10 by 10, 10 centimeters by 10 centimeters. Now the boy's measurement or the student's measurement is 9.9 centimeters by 9.9 centimeters. So there is error in his measurement, and that is what we want to calculate. And we know that error is equals to measurement minus true value. So what is the true value now? If you go back to the equation says a square is 10 centimeters by 10 centimeters. A student measures a side of the square as 9.9 centimeters. So the measured value now is 9.9. So our error will be equals to 9.9 minus the true value, which is 10 centimeters, minus 10. So the error therefore will be minus 0.1 centimeters, as the case may be. So we are going back to calculate the percentage error since we now know our error. So percentage error E will be equals to error all over true value times 100%. So we know our error, we know our true value. So we are looking for percentage error. So we now have it as our error is minus 0.1 over 10. If you like, you can put the centimeter, but the centimeter will eventually cancel out centimeters, times 100%. So if we continue with our calculation, 10 here, this centimeter cancel out centimeter, 10 into 10 is 1, 10 into 100% is 10%. So 10% times minus 0.1, so we have our error, percentage error, to be equals to minus 1%. But we cannot take minus 1 as our final answer because the length of a shape is a concrete something. So we have to remove the minus from our answer. So our final answer, therefore, the percentage error we are looking for is equals to 1%. So this is for A. Now let's go and find the percentage error in the area of the square. So it's the same square we are using, and this time we are calculating the error. The error in the area of the shape, that is B now. We know that the formula for area of a square, area, is equals to x times x. This will give us x square, s square. So, but the true area, which is this shape now, the area of this one, we call it area of the true shape, the area of the TV, will be equal to, TV means true value, is equals to 10 centimeters times 10 centimeters. and that will give us 100 centimeters square. And the area of the measured shape call it will be equal to 99.9 centimeters times 99.9 centimeters. So that will give us 98.01. So the error this time will be equal to 98.01 minus 100. Remember, they are centimeter square, so they will later cancel out. So our error now will be equal to, so our error is equals to minus 1.99. So the percentage error we are looking for will be equals to error all over true value times 100%. So this will give us minus 1.99 over 100 times 100%. So this will be equals to, 100 cancel 100. So the percent will multiply minus 1.99, and that will give us minus 1.99%. Like I said before, the area of a shape cannot take a negative value. So the percentage error also cannot take a negative value. So our final answer will be 1.99%. Therefore, the percentage error is equals to 1.99%. Thank you. Example 3. The length of a running track is measured and given as 700 meters. Find the percentage error if the length is measured A to the nearest meter, B to the nearest 10 meters, C to one significant figure. So remember one of the formulas we gave as percentage error to be error over measurement times 100%. So this is the formula we are going to use, because this value you are seeing here is not a true value, it is a measured value. So it's going to be our denominator in this formula. So the question A is saying that what number that when you approximate it to nearest meter you get 700. We have many of them. So when you approximate 699.5, you get to the nearest meter, you get a 700. The same thing with 699.6, 699.7, 699.8, 699.9, 700.0, 700.1, 700.2, 700.3, 700.4, 700.5, except this last one. All of these numbers, if you approximate them to the nearest meter, you will get 700 meters. Now, there are range of values. We have to consider this last one because of the last digit 5 and the last digit here 5. So, and we are going to use only this and this, the first and the last, because these are range of values. So that is why I said that when you are using this formula, your answer must be 2 or more, because you are dealing with the range of values. You are not sure which of the value you are looking for. So because any of these can give us these 700 meters, we are not just going to consider just one of the numbers and then conclude on our answers. No. So we must use the range of these values, the first and the last. Remember, the last one is not always part of it. I repeat, the last one is not always, because if you approximate this one to the nearest meter, it's supposed to be 701. So, but every of this one, if you approximate this one, it will give you 700. This one down to the first one. So, the value we are going to use here is going to be the first and the last. So, the first one here is 699.5, and the last one is 700.5. So, the values, the range of the values we are considering is 699.5 or 700.5, so that our error will be equals to 699.5 minus 700, and that will give us minus 0.5. Again, the error will still be equals to 700.5 minus 700 again will give us plus 0.5. So anytime you are using this formula, just know that your answer should be plus or minus. So this, our final error now will be equal to plus or minus 0.5. So if we are considering calculating our percentage error, we now have our error, which is plus or minus 0.5 all over our measurement, which is 700 times 100%. So if we continue with our calculation, this deal with this two zero digits, so percentage times this. Remember, if 7 divide this, we are going to get 7 plus or minus 1 over 14%, or plus or minus 0.071%. So this is our answer to the A part. So this is the percentage error. So let's consider the B part. The B, we have to the nearest 10 meters. Is the same thing. We are going to look for the range of values, as in which number that you approximate to the nearest meter. I mean 10 meters that give you this 700. The number should be 695 or 705. Like I told you, the last one is not always correct, but because we are dealing with the range of values, you know it will be 695 to 696, 697 down to 690. If you list them out, down to 600, so forth. Even 701, 704, 703, they are, if you approximate them to the nearest 10, you get 700. So, but the last of them is this 5, and is not always this thing. So, our error in this case will be equal to 695 minus 700, and that will give us minus 5. Again, 705 minus 700 will give us plus 5. So our error in all is equals to plus or minus 5, so that our percentage error will be equal to plus or minus 5 over 700 times 100%. So therefore percentage error will be equal to this 700 cancel as this, so we are going to have plus or minus 5 over 7 percent as our answer, or plus or minus 0.714%. So you can take any of this answer. Now let's move to the last one, that is the C part. The C part, we have to one significant figure. What are the numbers you can approximate to one significant figure and it will give you 700? We have many of them. We have 651. There are many of them, but we are going to take only 650 or 750. Remember, if we are to list them, this 750 will be the last one. Like 650, 660, 670, 680, 690, and so on and so forth. If you approximate all of them to the nearest, to one significant figure, even 651, 600, you know, as many of them, but we are going to consider only these two, because this is the beginning and this is the end, close to the end. But like we said, the last one is not always correct, so we are taking it because of 5. So our error therefore will now be equal to 650 minus 700. This will give us minus 50, and then 750 minus 700 will give us plus 50. So percentage error will now be error, which is plus or minus 50 over 700. So our error, don't forget, is equals to plus or minus 50. So times 100%. So if we continue our calculation, percentage error will be equal to this cancel this, this cancel this. So we have plus or minus 50 over 7%. So if you break it down, it can also give you plus or minus 7, plus or minus 7, because 7 into 50 will go 7 times. 7 can go into 49 points. 14%. So this is how to calculate this type of percentage error. Thank you and God bless you.